Sir, now it is appearing in YouTube, sir.
Okay, good. But your meeting is now streaming live on YouTube. It has come.
Yes.
It started, sir.
Yes, you can sit.
Afroz, ask our students whether it is in YouTube live or not.
Okay, sir. I'll go and check once. Sir, it is coming YouTube live stream nicely, sir.
Okay. How much time it will take after your session?
Sir, I think I can finish in 1.5 hours, sir.
Okay.
Good. Okay.
I won't be fast, sir.
Okay.
I will, in between, I'll check the timings, sir.
No,
Okay.
no time constraint. You take whatever time you want.
I think it is 11. We can start.
Only 11 members join sir YouTube లో దాన్ని క్రియేట్ చేస్తాను సార్.
Okay, okay.
Only if I make it down on this, it will be difficult for me to see the presentation.
మీకు ఇది ఓకే అయితే
ఇది okay. This is okay.
ఇప్పుడు చూపించారు కదా మేడం మీకు ఓకే అయితే
ఓకే అఫ్రోజ్
Okay,
సార్
Okay.
స్టార్ట్ చేస్తున్నాను సార్.
Okay, okay, start.
Good morning to all the participants of NAHEP sponsored virtual national workshop on application of HPLC in Pharmacokinetic Studies. So with the yesterday's lecture, I hope you all familiarized with the various components of HPLC and care and management for smooth functioning of the HPLC. Today is the virtual learning session in which you are going to have visual experience through videos along with explanations, starting from drug administration to chicken, blood sample collection at various intervals, sample processing, operation of HPLC in detail, and generation of data for further statistical analysis. The today's speaker for virtual learning session is Dr. Afroz Jahan, co-organizing secretary of this workshop and assistant professor contractual in the Department of Veterinary Pharmacology and Toxicology, NTR College of Veterinary Science, Gannavaram. She has very good knowledge and hands-on skill in HPLC operation. Now I request Dr. Afroz Jahan to start the session.
thank you
Dr.
so
Afroz
much.
Jahan, please.
Thank you so much, sir. So good morning, everyone. First of all, I would like to thank Dr. K. Bharvi sir and Dr. G.S. Rao sir for giving me this opportunity and believing in me. And today what I am going to discuss that virtual learning session, that is not just like a 1 year experience or like that. The thing is here, I am going to show you the demonstration, which will be just within 1.5 hours. But it's not to demoralize you, all of you. The thing is here, how frequently if we accompany our seniors, and how many molecules we take into we try to learn the thing, the more we will be learning about HPLC. So in continuation of yesterday's lecture, where Dr. Bharvi sir has given us a very good and elaborative and informative idea about HPLC and various components of HPLC, and how those components we can use for finding out the concentration of an unknown molecule, including the drug molecules, and like how we can go for like permutation and combinations as a starter. When we don't have a knowledge in HPLC, very nice explanation in yesterday's lecture we have got. So in continuation of yesterday's lecture, today I will have a virtual demonstration session on the pharmacokinetics of a drug in a chicken. So my learning of HPLC started long back when I joined here as a PhD scholar. And like when my seniors at that time, when they were doing standardization of albendazole, by seeing that, I thought that, oh, HPLC, it's really very easy and we can learn within 1 day. But it's not like that one night show. The thing is like when actual learning of HPLC for me started when we have one of our PG scholar, that is Dr. Usha. For her one phytomolecule we started standardizing. The thing is, if we are, I can say that we are unlucky person if we get a molecule standardized within 1 day or within 1 week. The thing is, we won't be able to learn so many things regarding kinetic. It's my personal experience. Most of the things, what type of chemicals, solvents, buffers we can use, that I came to learn when we were standardizing that MVSC scholars phytochemical through HPLC for detection by HPLC. So they are almost like we struggled for 3 months, and that was a crucial period in my life where I have started learning about HPLC and I got interest in HPLC. So the thing is, I request all the participants, suppose if your work, research work is not also on HPLC, and if any one of your fellow colleagues or your seniors, they are working on HPLC, try to accompany them so that you will be, with every molecule, we will be learning some new thing. There is no end to learning of HPLC. And till now also, like when we start standardizing a single molecule, we feel that like, okay, we know the things, but once we start standardization, there is lot of permutation and combinations, and it's not a one shot go. Another thing is the most crucial part is like standardization in matrix. Getting recently for one of my fellow colleague, we were standardizing one phytomolecule, and there what we could find that within 1 day we could standardize, and within third day we could get R square value. All these things I'll be discussing. R square value we got 1, but finally when we came for like matrix standardization, so it's really a challenging task to get standardized in matrix. So the thing is like the more we try to learn, the more we will be knowing about HPLC. So with this introductory session, let us start the today's session on a virtual demonstration on pharmacokinetics of meloxicam by reverse phase HPLC. So in coming to synopsis of today's talk, I am going to discuss in brief about general introduction, then how we will, if an unknown drug molecule is there, how we will be proceeding for its standardization, followed by its standardization in mobile phase. Then after its standardization in mobile phase, how we will proceed for standardization in matrix. And after its standardization in matrix, how we will be proceeding for animal experimentation. Okay. So now coming to, so the drug today, what we are going to show you for standardization is meloxicam. So meloxicam, it is a oxycam derivative, and we know that it is a long-acting, non-steroidal anti-inflammatory drug. So it possesses anti-inflammatory property, antipyretic property, and analgesic property, and it is preferentially COX-2 inhibitor. So before starting standardization of any molecule, the basic thing what we need to know is the chemical composition of that particular molecule. So here, this is the structure of meloxicam, where you can see here amine groups are there. Here, hydroxyl groups are there. So why we need to know about these amine groups or hydroxyl group? What is the need for us to know about the structure? So based on this presence of various like components or composition of this like amine group or hydroxyl group, we will try to check the solubility of the molecule, as well as based on this structure, we are going to decide the mobile phase. That based on this structure, mobile phase is predicted. So the first important thing when we are going to start standardization of any unknown molecule, the thing is we should have a clear idea about its chemical composition. The second point what we need to take into consideration is pKa value of that particular compound. So here for meloxicam, it is having two pKa values, that is 3.8 and 7.6. So what does this 2 pKa value means? It suggests that meloxicam will exist as a Zwitter ion. So it exists as a Zwitter ion between pH value of 5 and 9. So what is the need for us to know about this pKa value? Because through our pharmacology knowledge, we know that pKa is nothing else but it is the pH at which 50% of the drug molecule, 50% of the compound will be in ionized and unionized form. Okay, so based on this pK value, what we have to do is we have to check the pH of the mobile phase. The pH of the mobile phase will be adjusted based on this pK value, either 1 log unit up or 1 log unit down. Why 1 log unit up or down? Because as the definition suggests, it is the pK is the pH at which the compound exists in a 50% of ionized and unionized form. So we know that through HPLC, we can detect when the compound is in unionized form. So if we increase the pH towards 1 log unit up, or if we decrease the pH towards 1 log unit down, according to our Henderson-Hasselbalch equation knowledge, we know that it will be almost 90% in unionized form. So it will be easy for us to detect the molecule. So that the first thing what we need to know is structure, chemical composition of that particular molecule, what we are going to standardize, as well as its pKa value. Once these things are known, so based on the structure, we have to predict the solubility of the molecule. So generally for solubility, we will be using organic solvents. So why we will be using only organic solvents? Because in HPLC, the separation of compound is based on its polarity as well as its partition affinity. So we know that organic solvents, they are having wide range of both polar and non-polar solvents. So this is the solvent polarity chart where you can see they are having very less. This is a wide range of nanometer where this is the nanometer where they can be detected, and this is a wide range of their absorbance. So here we can see acetonitrile, which we most frequently use, is having very low absorbance value. So the thing is, here for solubility, we have to use organic solvent. And in organic solvent, first of all, just a pinch of molecule, what we want to standardize, we have to dissolve it. So here in this solvent polarity chart, you can appreciate here that this is the water is the most polar, whereas here cyclohexane is the most non-polar molecule. So here today's session, we are showing standardization of meloxicam with reversed phase HPLC. So based on yesterday's knowledge, you know that reverse phase HPLC means here the mobile phase will be polar to semi-polar in nature. So whatever the molecule we have selected, that molecule we have to see its solubility in polar to semi-polar range of chemicals. So here water is the most polar, followed by methanol, ethanol, acetic acid. But mostly we will prefer to see the solubility of the test compound in acetonitrile, or either combination of acetonitrile methanol, or combination of acetonitrile with water, or combination of acetonitrile with 1% acetic acid in required ratios. So here for meloxicam, when we started checking its solubility, we could find that it was solubilized in 1:1 ratio of acetic acid and acetonitrile. That means 1% acetic acid solution was prepared, and like half strength of acetic acid and half strength of this acetonitrile, that solvent was used for solubilizing this meloxicam. So our stock solution was prepared in the solvent, which is a composition of like 1% acetic acid and acetonitrile in 1:1 ratio. So this is the solvent polarity chart where we can see water is the most polar solvent, followed by acetonitrile, methanol, isopropanol. Here we will be using for cleaning of the injector, because what we in our lab we are using Simasdo HPLC system. So we are having a manual injector. So in between for maintenance of that injector, we will be using this isopropanol. Then followed by acetone, ethyl acetate, ethyl acetate, dichloromethane, and hexane. But most frequently, we will be using a composition of either water, acetonitrile, and methanol, if at all some organic HPLC grade salts. Okay. Now, once the drug is soluble in the organic solvent, and then we have to prepare the stock solution. So here for meloxicam, we have prepared the stock solution in acetic acid and acetonitrile. That is, acetic acid is 1%. Okay. So once we have fixed out the we have checked the solubility, then we have to, based on pK value of the drug molecule, we have to go for trial and error of selecting the mobile phase. So the composition of mobile phase is decided based on permutation and combination of various organic solvents as well as some buffering salts. So here the salts what we are using is, they should be of HPLC grade. Why? Because they will be having high purity, so the contamination will be very, very less. Okay. So here we have prepared the, it's not like within one shot we can standardize the mobile phase. The thing is, with lot of, once we see the solubility of the molecule, then based on that we will, based on the literature survey, we will try to do permutation and combinations, and based on permutations and combinations, then mobile phase composition is fixed. So here sometimes what happens is, no, it's not mandatory that stock concentration we can prepare in any solvent. We can go for preparation of the stock concentration in mobile phase itself if the test compound is completely soluble. There should not be any precipitate formation. So once the composition of mobile phase is fixed here, so in my subsequent slides, I will be showing you what mobile phase we have fixed here and how to do the calculation. So after that mobile phase is standardized, then what we have to do is, we have to prepare this working standards in mobile phase. So this is a flow chart where we have to, how we will be preparing the working standard. So generally the stock solution of any molecule is 1 mg per ml. So here what we like, from 1 mg per ml means the concentration will be 1 microgram per microliter. So for HPLC, generally we will go up to detection up to picogram, nanogram. So what we need to do is, here we need to prepare working standards. So to prepare this working standards, generally in our lab, we start from 8 microgram and we go up to 0.003 microgram per ml. So the thing is, if we need to prepare this 8 microgram per ml, directly I can take from the standard stock solution 8 microliter and I can add 992 microliter of the solvent to make it 8 microgram per ml. But the thing is here, what that 8 microliter, what I will be taking, even though I am using that very sensitive pipette, what will happen is, like this 8 microliter is a very less volume. So there may be chances of some error and we may not get the accurate results. So in that situation, first we have to go for preparing like 10 times higher concentration one set, then we have to go for 10 times dilution. So here generally in our lab, what we are doing is, suppose we need to go for 8 microgram per ml. So here first we will prepare 80 microgram per ml from the stock solution. So to prepare that one, we will be using 80 microliter and 920 microliter of the solvent. So the final concentration will be 80 microgram per ml. Then from here, we will be going for serial dilution. Okay, so the next year it will be 40 micrograms. Similarly, whatever the concentration we need to like standardize that range, we have to go on doing the serial dilution. So when first step in standardization of any test compound is standardization by spectrophotometer. So for this what that I am saying about preparation of working standard, it is for like standardization by HPLC. But if we need to go for standardization by spectrophotometer, for that we have to proceed with 1 mg per ml followed by 0.5 mg per ml. Serial dilutions we will make up to 0.03 microgram per ml. Okay, once we will make this serial dilution up to 0.03 microgram per ml in for standardization by spectrophotometer. After that, whatever the solvent we have used. So here for meloxicam, we have used that acetic acid 1% 1 part and acetonitrile 1 part. So that also we have to scan it, because the absorbance of the solvent should be below the concentration what we are going to estimate. Okay. Next thing is here, the dilutions I have said in my previous slide that we are making it in mobile phase. So for dilutions also, this mobile phase also we have to go for scanning. Okay. So now this here we have seen that once we prepare this set of like one set of our serial dilution, then from here we have to go for 10 times dilution. So generally what we are following is 0.15 microgram per ml. If from this concentration we take 100 microliter and add 900 microliter of solvent, our concentration will be 0.015 microgram per ml. So here we will start from lower concentration and we will go on making the 10 times dilution here. So this will be our working solution. Why? Because here you can see that here the volume is not equal, 80 microliter. Then here we have gone for serial dilution. So here like similarity is not there. So here we have not exposed all the concentration to the similar condition. So once we go for 10 times dilution, here you can appreciate that from all the concentrations we have taken 100 microliter and we have added equal quantity of or equal volume of solvent. So that means here we are exposing all the concentrations to the same conditions. So if at all any error occurs, that error will be similar for all the concentrations. That's the reason why we will be going in this fashion in our lab for doing any standardization procedure. Okay. So next is the mobile phase. So here once we have standardized the composition of mobile phase. So for here for meloxicam, our mobile phase is 0.05 molar sodium acetate buffer and acetonitrile. So here 0.05 molar sodium acetate buffer is 60 parts and acetonitrile is 40 parts. So once when we prepare this mobile phase, this is the for your reference, I have shown you that how we will be calculating 0.05 molar sodium acetate buffer. So like for initially when we are doing standardization, we need not prepare liters of buffers. We need to prepare just 300 to 500 ml of buffer only. So here this is the calculation that for 500 ml of 0.05 molar sodium acetate buffer, how much I should weigh sodium acetate based on its molecular weight. So once this what is called like my buffer is ready, it is completely with the help of magnetic stirrer. Once it is completely solubilized, I should not make the volume up to 500 ml because here I have to adjust the pH. So what first we have adjusted the pH to 5.5 with glacial acetic acid, that is HPLC pure grade. Then the pH was brought back to 6 with triethylamine. Why this pH was brought back to 6 here? Because initially in my first slide here, I have shown you chemical structure. So here you can see that we are having amine group. So that means presence of amine group means they can be detected very good, or we can have a very good resolution when the pH is towards basic side. Okay, so that's the reason why here the pH was brought back to 6 with triethylamine. Okay, once the pH is brought back to 6 pH with triethylamine, then the volume will be adjusted to 500 ml, whatever the volume we require to prepare for that particular buffer. Okay, so so this is about like how we will be going for preparation of mobile phase. So once the mobile phase composition is finalized, once we have checked the solubility of the molecule, then first step is we have to go for standardization by spectrophotometer. Why we should proceed for standardization by spectrophotometer? Because like we can save the time as well as solvent, as well as we can reduce the cost of the trial. So here generally in our lab what we are practicing is, first of all, after checking the solubility, as I have said that we will make some 5 working concentrations, and then first of all we will go for scanning the test molecule with the higher concentration for a wide scanning, that is scan mode between 200 to 600 nanometer range. Why we need to scan between this range? Because we know that most of the drug molecule, they are having their molecular weight between 100 to 700 nanometer. And that too, and we know that UV visible range is between 200 to 800 nanometers. So here, like for meloxicam, we are going to use UV vis detector. That's why, like, that is one of the reason that we will be scanning the molecule between 200 to 600 nanometer range with a bandwidth of 2 nanometer difference. And like for that higher concentration, once it is scanned by spectrophotometer, we will be seeing the maximum absorbance of that particular test molecule. So once that, suppose if the test molecule is showing the maximum absorbance between 360 nanometer, that means we will be fixing that nanometer as our wavelength, detection wavelength for HPLC. So here when we did scanning of this meloxicam, we could find that its maximum absorbance is at 355 nanometers. So the detection wavelength for HPLC for meloxicam was fixed at 355 nanometers. Okay, once that detection wavelength is finalized, then what we have to do is at that particular wavelength, we have to go for scanning of all the solvent as well as our 5 concentration of test molecules. So first we have to start with the solvent, whatever the solvent we have used one by one. So here first, as I have said that solubility we have checked in 1% acetic acid plus acetonitrile. So first individually I will check the at 355 nanometer wavelength, I will be checking the absorbance value of 1% acetic acid. So that value we will record it. Then followed by acetonitrile. Then that combination we will be recording. Followed by mobile phase. Followed by our increasing concentrations of meloxicam. We will go for recording its absorbance value. So here what we need to take into consideration is, suppose the least concentration what we can detect by spectrophotometer is 0.03 microgram per ml. So that 0.03 mg per ml. So 0.03 mg per ml, what absorbance value it is showing. So whatever the solvents we have used here, that solvent should have the absorbance value less than that 0.03 mg per ml. And then whatever the concentration, 5 concentration we have selected, we will just plot it concentration versus the absorbance value. It should have a linearity. That means it should have 0.9 to 1 linear R square value. Then only we can say that this method is standardized by spectrophotometer. Once the method is standardized by spectrophotometer, then we will go for HPLC. That means after standardization by spectrophotometer, we will proceed for standardization in mobile phase. So here in my previous slide, I have shown how to prepare working standards and how to prepare mobile phase. So once the mobile phase 500 ml I have prepared, then we have one of the crucial thing which we need to take into consideration is filtration of the buffer. Why we need to filter the buffer? Because even though we are using HPLC grade solvent and HPLC grade salts for buffers, but still it will have some 1%, 0.1 to 1% of impurities. So to remove those impurities, we need to go for filtration of the buffer. So here I'll be playing the video of that buffer, filtration of the buffer. This is the filtration apparatus. So with vacuum pump, here the pressure you can appreciate, and here like after keeping this equipment, here we'll be using 0.45 micron meter diameter of that filter papers, and then we will, here you can appreciate that we are doing filtration of the buffer. This filtration of buffer is through vacuum. And one more thing I would like to emphasize, that when we are we have standardized with spectrophotometer and we are proceeding for standardization in mobile phase by HPLC, then in that situation, suppose if our mobile phase is having a buffer as well as organic solvent composition, then it's better to reduce the volume and wastage of the mobile phase. It's better to prepare the isocratic phase of mobile phase. So here isocratic means, generally here I have said that the buffer is 60 parts 0.05 molar sodium acetate buffer and 40 parts is acetonitrile. So when we are in an initial phase stage of our standardization, what we need to do is we have to prepare isocratic mode of our mobile phase. Isocratic means that 60 part as well as 40 part we will mix together and then we will be doing the filtration. So here what you are seeing is not the individual filtration of buffer, here it is a isocratic mode of filtration. So suppose if for 100 ml my buffer is 60 parts and for acetonitrile organic solvent is 40 parts, so for 500 ml accordingly I will be doing the calculations and then we will do filtration like that. Once the filtration is done, then whatever the buffer we or that isocratic mobile phase we have filtered, we have to go for sonication, because in the video you have seen that there is lot of bubble formation. So we have to minimize those bubbles or to remove the dissolved bubbles, we have to go for sonication. And another way of removing the bubbles is we can go for degassing. Online degassing unit will be there. So through online degassing software, we can degas the mobile phase. But in our lab, generally, we will be practicing sonication for degassing the mobile phase or buffer after filtration. Okay, now in this slide, we can appreciate the working, here we can see the working principle of HPLC. So once the solvent is ready, the solvent will be degassed by online degassing unit, and then it will be going to the pump. The pump will be sending the mobile phase to the column, and once here the sample will be injected and then sample will be carried along with the mobile phase to the column, and from column it will be going to detector where the compound will be detected and which will be visualized on the monitor, and waste will be collected in the waste container. So this is our lab where we are having Simasto LC10 version of HPLC system. So here this is a degassing unit. Here this is a pump. This is here detector, and this is our column, and this is our UV visible detector, and this is we are having recently we have got fluorescent detector, and this is we are having here low pressure gradient quaternary gradient pump. So quaternary means we are having 4 inlets for 4 different type of solvent. But here in this pictorial representation, you can see that I have kept here measuring cylinder. So this is nothing, instead of making it as a gradient, I have kept it as a initial phase of standardization. I have kept it as a isocratic mode. Okay. And this is the software here. Okay. Now before going for virtual demonstration how the equipment is started and how we are going to set the chromatographic conditions and all those things, let me explain few things. Once we are starting the equipment and software, then we have to set the conditions for purging. So what is the need for this purging? Because we have seen in this previous image, you have seen that these are having lot of tubings. Whatever the solvent reservoir containers are there, they are having tubings. So these tubings has to be free of gas bubble. So that's the need that we need to go for purging. So here whatever the solvent we are going to use, with all the solvent we have to do the purging one by one. So generally the purging is 1 ml per minute, and by default in this Simasto system it is 3 minutes. That means it will be taking 3 ml for 3 minutes. So in our today's when we are standardizing by mobile phase, first when we are keeping as isocratic mode, then only we have to purge only with the mobile phase. Then at the end of our like running the experimentation, we will be washing the column. So generally we will be washing the column with milq or HPLC grade water if continuously we are going to run the HPLC system. So like so for washing at the end also I should go for purging the milq water. But suppose if I am keeping as a gradient in a gradient mode, that means I will have in one container I will have 0.05 molar sodium acetate buffer. In one container I will have acetonitrile. In one container I will have milq water. So one by one I have to go for purging with all the solvent or solution what I am going to use for HPLC system. And one more thing we need to take into consideration is whenever we are using buffer, we should not immediately purge with acetonitrile or methanol. Why? Because acetonitrile or methanol, it is chilled and like it will crystallize these salts whatever is present in the buffer. So whenever we are doing like standardization or whenever we are doing purging, we have to use either like a buffer followed by water then followed by acetonitrile, or acetonitrile followed by our water then followed by buffer. Buffer should not be accompanied with acetonitrile or methanol because it may crystallize the salts which are dissolved in the which are present in the buffer, and it may block the column, and there will be increase in the pressure. Because that is my personal experience when one of our students, when they were using phosphate buffer, that time like column was not washed properly, and so and like immediately after using phosphate buffer, instead of washing the column with milq water, the column was washed with acetonitrile, and then it was like pressure was constantly increasing, and afterward the column was after that the pump was shut down and the equipment was not working. So when we called the like technicians and like maintenance person, we could see, I myself have seen those crystals. So generally I don't appreciate that buffer should be followed by acetonitrile purging and methanol. Buffer should be followed by milq water or HPLC grade water only for purging. Another one thing we need to take into consideration is the like molar strength of the buffer. It should not be beyond 50 millimolar. Why? Because if we increase more amount of buffer, the salt will, the more concentration of salt, it will crystallize, and it will be like in that for detection of the molecule it will be somewhat difficult. So that's why in our lab like whatever these tips I have learned, I have learned from my mentor Dr. G.S. Rao, who is well known for kinetics. So like in our lab generally we don't prefer more than 50 millimolar of any salt. Okay, now here the chromatographic condition for meloxicam what we have used is like a mobile phase is 0.05 molar sodium acetate buffer 60 part, acetonitrile 40 part, and the pH was adjusted to 6 with triethylamine. The run time here is 10 minutes. Stationary phase what we have used is C18 column. Oven temperature we have maintained at 35 degrees centigrade. Flow rate is 0.8 ml per minute, and detector here is UV vis, and the detection wavelength is 355 nanometer. So here in this video, I will be explaining one by one what we are doing. So this is like HPLC system. One thing, it has to be battery backup. So that was battery backup. Then after that, all the like wirings has to be put on. After that, the system has to be put on. Once the system is on, then the equipment column followed by detector followed by pump has to be put on. After that, as I have said, we are having LC10 software. So lab solution software has to be, the equipment has to be connected with the software. So here UV detection we are doing. So UV software I am connecting here. So here you can see not connected. After that, once it is connected to the software, ready will be, every instrumentation will have its own software. Okay, here I am setting the condition for purging. So as I have said that for purging, the flow rate should be 1 ml per minute. Here in ours is quaternary gradient. So here we are keeping D is nothing, we are having molecule water. And in A stellate, I have kept A is my this one, what is called mobile phase. So once that purging condition is set, then the valve is open. Then purge button is clicked and the tubings are purged. Why the valve has to be open? Because the solution should not enter the solution, whatever the solvents we are doing purging for clearing the tubing, it should not enter through the pump. That's why the valve has to be open. Okay, once the so here I have shown in this video only purging with one solvent, but all the solvents whatever we are using, with all the solvents we have to go on purging. After that, like here you can see the settings of the chromatographic conditions. So flow rate is 0.8 ml. Then here B is my acetonitrile. Here this is the runtime 10 minutes. But when we are standardizing any protocol, generally for the first concentration, for only 3 concentration in our lab, we will be injecting into the HPLC system, and then we will be keeping the runtime for half an hour to know the retention time of that particular molecule. This is the wave detection wavelength, 355. Then oven temperature 35 degree. So after that, this valve will be closed, because it has to mobile phase has to go through pump into the column. Then oven button will be put on so that the temperature, once the temperature, here you can see set temperature is 35, actually it is showing 29. So once it reaches 35, then this pump button will be pressed, and here you can appreciate how the pressure is increasing. So once this chromatographic condition is set and the pump is started, and once the pressure stabilizes, after stabilization of the pressure, minimum the equipment should run for 1.5 hours in the mobile phase. Actually, like in some of the situations, some people uses 45 minutes to 1 hour, but it's my personal experience here that even after 1 hour, if we start injecting the sample, the pressure starts fluctuating. So it's better that minimum we have to stabilize the pressure for 1.5 hours. So for this chromatographic condition, the pressure was stabilized generally like based on, because every day we have to prepare fresh buffer. So based upon like minute changes into the salt composition, the pressure gets fluctuates and it stabilizes between 70 to 80 kgf for these chromatographic conditions. Here you can appreciate this pressure is fluctuating. Generally for if only acetonitrile we are using, the pressure will be between 30 to 40. Water, if we are keeping, it will have like pressure around 40 to 50 like that. Methanol around 60 pressure will be there, but here it is a composition of like acetonitrile and salt, so the pressure will be somewhat high. So here you can see that straight line is coming, like we have to keep it minimum for 1.5 hours for stabilization. Okay, once the pressure is getting stabilized, meanwhile, we have to go for preparation of working standards from the stock solution. So I have already shown the flow chart, how we are preparing in our lab working solution from the stock solution. And then along with working solution, we have to inject all other solvents what we have used. for preparing those working solutions. Why we need to inject all other solvent? Because whatever is the retention time for our test compound, at that particular retention time, we have to check that whether mobile phase or acetonitrile or buffer is not at all having peak, or if at all it is having the peak intensity or resolution should be less than the least detected concentration. So for that reason, we need to inject, prepare working standards as well as all the solvents what we have used for HPLC. Okay, next video, I'll be showing you how the sample is after stabilization of the pressure, how we are injecting the sample, then how to retrieve the data, then how to plot the data in Excel sheet and how to get R square, then washing of the column and how to put off the equipment. So this is for just, I will be showing for mobile phase, then followed by these steps all I won't show for plasma standardization and like animal experimentation. Only how the graph is running, that I will be showing the things. Okay, and when we will be injecting the samples in HPLC system, as our HPLC system, we are having manual injector, that is rheodine injector. So after injecting the sample, what we are doing here is we have to wash the syringe, Hamilton syringe. So what we are practicing is triplicates of the solvent we are keeping, and each solvent we are washing minimum 10 times. But I don't prefer washing minimum of 10 times in each solvent. I generally prefer, if 2 ml append of tube is there, up to 1 ml in each test, in each append of tube. Why? Because I myself, I will be when I will be showing the overlay chromatogram, there we can see that if washing is not proper, there will be some contamination which will be carried forwarded for the next injection. So that's why I personally emphasize in our lab that we should minimum wash in here, that first append of tube up to 1 ml, followed by second, then followed by third. Why triplicate washing? Because here we will have nil concentration residues of the previous injection. Okay. So once here you can see the time 1.5 hours almost it has happened. Once the pressure is stabilized, then first of all we have to create the folder where we want to save our data. Then we have to start the single run. We have to browse the folder. Then first here I'll be injecting acetonitrile. So this is our rheodine injector. Manually we are injecting. This is Hamilton syringe. So here you can appreciate pressure is stabilized at 85 kgf. Wavelength is 355. Flow rate is 0.8 ml per minute. So this here the run has started. Here run time is 10 minutes. Even here it is like start single run. In between, if suppose injection is not proper, we can stop it here or stop, and then we can wait for 10 minutes or like 15 minutes, then we can go for re-injecting. But generally I don't prefer, because like it may create some issues to the system. So it's better, even though the like peak is not coming proper, it's better to let that get completed. No, next sodium acetate we are injecting, let that run get completed, and then to repeat the injection once again. So here now sodium acetate buffer is injected. Mobile phase. First concentration 0.03 microgram per ml. So here mobile phase was not having peak, and here this is 0.03 microgram per ml. That is approximately 4.99 something retention time. Here in this video I can't see show you, but when we keep, like when live it is running, at that time when you keep the cursor here, we will be here, it will be intensity as well as time will be displayed here. Point 0.06 microgram per ml. So here you can appreciate 355 nanometer. Here chromatography condition flow rate is this much. A here it is by default. So 40 is acetonitrile, A is our mobile phase. So here you can appreciate 0.06 microgram per ml peak. So with increasing concentration, this peak height as well as peak area should increase. And so when we will go for quantification, either peak area or peak height we will take into consideration for linearity. Here we are getting very nice peak, but generally peak doesn't come this much nice. Many times we have faced front tailing problem, back tailing, shouldering, like extraction problem. So the thing is, it's like just trial and error, and the more you do, the more you learn. So in between concentrations, I have skipped it. Now higher concentration, that peak I will be showing. 8 microgram per ml. So earlier you can appreciate here I have zoomed it to 1 MV. Now it is 10 because like it is the higher peak. So that's means higher concentration peak. So when we are starting with the lower concentration and mobile mobile phase, that time we have to zoom it to 1 so that we can appreciate slight change in peak area or peak height. But before running in this, after standardization in mobile phase, before running, after standardization by spectrophotometer, when we proceed for standardization by mobile phase, instead of going from this lower to higher concentration, it's better to go for only 3 higher concentrations so that we will be knowing linearity and we will be knowing that peak retention time. So based on that, whether peak is getting detected or not, based on that we can do slight modification, permutation and combinations of the mobile phase, trial and error. So no need of like in initial stages, no need of going for like from lower to higher concentration. Once that mobile phase is working and the peak is really getting detected, then we can go for taking 4 to 5 6 minimum 5 concentrations, and then we can go for standardization in mobile phase. But generally I don't prefer like going for 1 or 2 concentration. I generally in our lab I encourage for my juniors also, for everything minimum 5 concentration we starts doing the thing here in our lab, so that we will have a clarity. Sometimes higher concentration may show increasing trend, but lower concentration may not be detected and they may not be in the linear range. So for that reason I generally prefer to do all the lower to higher 5 concentrations. Okay, once the run is completed, how to retrieve the data, I will be showing you. So here just we will be like browsing the folder, then main, then close. Then here mobile phase, this is like overlay chromatogram, 0.03, you can appreciate 0.6 increasing trend is there, 0.125, 0.25, 0.5, 1, 2, 4, 8, like that all are in increasing trend, and that too retention time has not deviated. So that is how like overlay. Then here data analysis will go again main, then we will go for data analysis, then we can how to copy the data. So we will create a Excel sheet. There whatever the concentrations we have used, that we will write, then peak area as well as peak height both we will copy and paste here, that from the software one by one here that retention time is 4.78. Area and height we will copy and we will paste it into the Excel sheet. Then this is how we will insert, draw the standard calibration curve, then trend line, and here R square you can appreciate 0.999 it is. With peak area. Now peak height we will keep. So it is 0.999. Both with area and height it is 0.999. Then how to copy the chromatogram? So first we will prepare the overlay chromatogram, then right click it, copy it, and just we can paste it into Word document. Now here, like after the last concentration is injected, here I am setting the condition for washing. Minimum half an hour after last injection, the system should run in mobile phase. After half an hour, the system running in mobile phase, washing conditions are set. So for washing, 0.3 ml flow rate is kept, and that with water, if we are going to do continuously HPLC, then it's better to wash the column with HPLC grade water. But suppose if we want to put off finally the system and we want to do the experimentation after 1 week or 1 month, then in that situation, first minimum 1 hour we should wash the column with water, then followed by minimum 1 hour we have to wash the column with acetonitrile to preserve the column. Then this, after that we have to put off, after like washing is completed 1.5 hour, pump is put off, so the pressure will come here 0. Once the pressure comes 0, then the system is put off. Why we should not keep the column in water? Because there may be chances of fungal growth. So in that situation, if we don't want to use regularly, after 1 week we want to restart the system. So in that situation, we have to go for preserving the column in acetonitrile. This is how, like a pump followed by detector followed by column is put off. Then the system is put off. Okay, this is about how it is standardized in mobile phase. So once we get standardized in mobile phase R square between 0.9 to 1, then we can proceed with the standardization in matrix. So to standardize in matrix, suppose here we are going to do standardization of meloxicam in poultry. So here poultry plasma only we have to use it. So that plasma we have to, first blood we have to collect in heparinized vials, and then plasma we have to separate, and that plasma has to be spiked with known concentration. So this is the overlay chromatogram of meloxicam in mobile phase. So this here you can see this is mobile phase, black color, you can see straight line 0.03, 0.6, 125 like that with increasing retention. This is the standard calibration curve in mobile phase. This is with area, this is with height. So R square is, and this is our equation, y is equal to mx plus c. So this equation we are going to use for quantification of the concentration. Okay. Now next, once it is standardized in mobile phase, next step is standardization in matrix. So here our matrix is plasma. So plasma we have to separate it. After separation, we have to use blank plasma without any drug, and remaining plasma we have to spike it with known concentrations of test compound. So how we have prepared working solutions in mobile phase, that flow chart I have shown you, in the similar fashion we have to prepare our working standards in matrix. So here instead of solvent we will be using matrix. So suppose if I have used 100 microliter of test compound concentration and 900 microliter of solvent, so when we want to standardize in matrix, there we have to use 900 microliter of your plasma or tissue sample or any tissue homogenate or liver homogenate, whatever is your matrix. Okay, so that adding of known concentration into the matrix is called as spiking. Once the concentration is spiked, we have to add, so that test compound has to be extracted from the plasma, isn't it? So to extract it, we have to go for extraction procedure. Why? Because in free form only the drug will be available, not in the tissue bound form. So free form of the drug only we are going to estimate by HPLC. So that's why from the matrix it has to be extracted. So here plasma, which contains the measured analyte, 1:1 ratio. For extraction solvent we have used acetonitrile. Okay, once it is, then we have to vortex it for high speed for 20 seconds. Then we have to go for centrifugation, that is 9000 G, 10 minutes at 4 degree chilled condition, refrigerated condition. Then supernatant we have transferred, and to supernatant equal quantity of HPLC grade water is added. And then it has to be filtered with 0.2 micron nylon membrane syringe driven filter. This is that filter. And then that filtrate 20 microliter has to be injected into the HPLC system for analysis. So here in this video, we will be seeing how to inject the sample and how in plasma we have standardized. So after stabilization, I am not showing. So blank we have injected. Blank means plasma matrix without any known concentration of the analyte. And blank also we have to process in a similar fashion. Here it is not zoomed in this video, so that's why it is not shown properly. Next blank I'll be injecting, then it will be zoomed. Blank minimum 2 times we have to inject, 2 different blanks we have to keep. So next first concentration injection. 0.03 here I have injected in matrix. So here see I have zoomed it. Here you can see 1, when it is zoomed, here you can see this is matrix interference. So this is 0.03 peak. So how we can differentiate that whether the standardization is done in mobile phase or matrix? By seeing the chromatogram, is the difference lies here, the matrix interference. In mobile phase we were not having this matrix interference, whereas in what is called when we are standardizing in matrix we are having this matrix interference. Next is 0.06 injection in matrix. 0.06, you can appreciate increasing trend. Next is 0.125. Here runtime we have kept 8 minutes. Why? Because our peak was coming at 4.9. So why to waste mobile phase? When we did standardization first in mobile phase, runtime was 10 minutes, but for plasma matrix, we have reduced it runtime to 8 minutes here, 8.5 minutes we kept runtime because our retention time was 4.9. So here you can see what I was saying, that washing of the needle, isn't it, after injection, manual injector. If washing is not proper, here that previous injection, some contamination will come. So that's the reason why I prefer to wash the needle or syringe, Hamilton syringe for more times. So this is a overlay chromatogram in matrix. Here you can appreciate all the content. See here, this is, once again, I will show you that peak. Here you see here, no mobile phase interference is there here. When we have done standardization in mobile phase, but here you can appreciate this matrix interference is there, matrix interference. So that's how we can differentiate that whether the standardization is done in matrix or whether the standardization is done in mobile phase. So this is standard calibration curve in matrix here. This is why we need to do standard calibration curve in matrix, is because this is going to give us the exact picture when we are doing the animal experimentation. Then the exact concentration what we will be calculating will be by using this exact concentration we can determine by if we have done standardization in matrix by using this equation. So now coming to animal experimentation, once the test compound is standardized in matrix, then we have to proceed with animal experimentation. So here we have taken bird. So like meloxicam for oral dosing, we have got oral bolus formulation of meloxicam, that is Malonex from Intas Pharmaceuticals. And then that was crushed into powder weight, and like weight by volume, we know M1 V1, like accordingly we have calculated the thing, and 0.4% suspension was prepared in distilled water. So 0.4% means 400 mg per 100 ml. That means 4 mg. So the concentration was 4 mg per ml. So we know that dose of meloxicam in bird is 2 mg per kg body weight. So here what we have done is we have used 2 kg more, 2 or more than 2 kg above body weight bird. So if it is like the dose is 2 mg per kg body weight, so for 2 kg body weight directly 4 mg is needed. So if directly I dose 1 ml of 0.4% suspension, then the dose will be 4 mg. So the maximum volume what we can in dose or administer in bird is maximum up to 2 ml. So that's why we have prepared calculated prior calculation based on this dose and body weight of the animal, and then we have prepared 0.4% suspension. So whatever the test compound you need to go for oral dosing based on your experimental protocol, you have to prepare this oral administration dose solution. Okay, now like next step is like after at predetermined time interval after oral dosing, we have to collect the blood samples. So blood samples we can directly collect in vacutainers, heparinized vacutainers or EDTA vials. But the thing is like we don't require like 1 ml or 2 ml of blood sample. We require hardly 0.5 ml of blood sample. So what is the need for us to go for using vacutainers? So in that situation, generally in our lab, we prefer preparation of heparin. So we will be using, we use 20,000 international unit per vial that heparin that we dissolve in 20 ml of PBS. Why PBS not distilled water? Because distilled water, it will cause hemolysis of the blood. PBS is a physiological salt solution. That's why there won't be any hemolysis. So when the heparin as anticoagulant, when the calculation we have done, 17.7 international unit is needed for 1 ml of blood. So that means like 17 microliter. If we take heparin, it will be sufficient for 1 ml of blood. So generally we will be using approximately 10 microliter for 0.5 ml of blood collection. So previous day we make ready all the heparinized vials for time and do the marking and all those things, and then we proceed for animal experimentation. So this is how the bird is handled. Before oral dosing, this is the bird. Its weight was 2.2 kg. So for handling, the thing is we have to lift the neck straight so that there won't be any choking when we are administering the dose. So weight of the bird was 2.2 kg. So the volume administered was 1.1 ml of the meloxicam suspension. So here you can see dosing. Okay, when we are proceeding for animal experimentation, prior to dosing, we have to collect the blank sample, 0-minute sample, then dosing. After this, that predetermined time interval. So before going for showing the blood collection point, this is the we have collected the blood from tarsal vein as well as wing vein. So it's like earlier we through our UG knowledge we will be knowing that only like wing vein we can go for collection of blood sample in bird, but like my mentor, he showed us that like we can go for tarsal vein collection, and it's my personal experience that whether 15 time point predetermined time points are there or 20, tarsal vein we will have less hematoma and we can collect more number of samples as compared to wing vein, because wing vein they are more prone for hematoma formation and they are very fragile and we have to be very careful. But in case of tarsal vein, it's very easy to collect the blood sample without formation of hematoma. So this is the course of the tarsal vein. So this is here. If we keep pressure here on the medial aspect, we will be seeing here the tarsal vein course. So it's easy. Up to this point, we can easily collect. Even from the same point, we can collect number of samples without any hematoma formation. This is like wing vein. So this is a blood collection from wing vein. So this was our sampling time. 0 minute means before administration of oral dose of meloxicam. Then 0.166 minute means 10 minute. It was converted into hour, 15 minute, 30 minutes, 45 minutes, 1 hour, 1.5. Why we need to keep this many frequent collection up to 2 hours? Because our route of administration for meloxicam is oral, and like we have to see the course of like drug absorption. So that's why this much frequent intervals we have to keep up to 2 hours. Then after 2 hours, 3 hours, 4 hours, 6 hours, 8, 12, 24. Generally, most of the molecule by 24 hours, it will be eliminated. Like concentration, plasma concentration comes down, but like we have to do trial run in before starting of our actual experimentation. We have to do trial run in 1 or 2 bird, and then we have to run the sample. So here when we did trial run, we could find it out even after 24 hours, still that concentration has, plasma concentration of meloxicam has not come down. So we proceeded up to 36 hours, and here that in graphical representation you will be appreciating. So this is how collection from tarsal vein. Here you can see I have pressurized here to raise the vein, and once I start collecting, we have to leave that one. This is wing vein collection. Here this already few points we have collected. So here you can see hematoma formation. So that's why for wing vein it's better to go for insulin syringe instead of going for like a like 2.5 ml syringe, so that we can minimize the hematoma formation. So here that is different neck separate side. Okay, so once the blood sample is collected at predetermined time after dosing wing vein and tarsal vein, then the blood sample has to be centrifuged at 3000 rpm for 15 minutes at 4 degree, and the plasma was separated and was kept stored at -80 degrees centigrade. If you don't want to store, you can immediately proceed for the extraction procedure, what I have discussed when we have discussed about standardization in matrix. Same extraction procedure we can follow, and after extraction the whatever the means after extraction we have got the sample that we can inject into the HPLC system. So extraction of sample already I have discussed. Now here injection of sample I'll be showing for animal experimentation. So after 1.5, this is 2 hours stabilization I have kept. We will browse the folder, then bird, then here 0 minute. That means before administration of the drug. So here you can see 0 minute, there was no drug sample. No peak, detectable peak at 0 minute at 4.9 retention time, 4.7 retention time. So next sample is being injected. Next here 10 minute. So here you can appreciate a small peak 10 minute. Next is 15-minute sample. So here you can see this peak. Earlier it was not there. So this is because of not proper washing of the syringe. So here also you can appreciate at 15 minutes small peak. There was not much difference when we keep overlay chromatogram, not much difference for 10 minute and 15-minute peak. Next is here 30-minute sample injected. So here you can appreciate 30-minute peak. So then how to get the overlay chromatogram for that in sample, like animal experimentation, what we have done, data analysis, we have to proceed. Then main, data comparison, then all 0 minute. Could you see here straight line for 0 minute? Then 10 minute, you can appreciate here 15 minute, no much difference. 30 minute. Okay, here you can see up to 1.5 hours, 1.5 hour, there was increasing trend. From 2 hours, there was decreasing. That means the Cmax was up to 1.5 hour. 3 hours. 4, 6, 8, 12, 24, 36. So these, whatever you are seeing here is, this is not because of proper washing of the syringes. So that's why even though if it takes time, the syringe has to be washed properly. This is about like how overlay chromatogram. Now this is how like we will go for calculation of like calculated concentration. So here like for different time interval, peak area, peak height we will plot. After that what we have to do is standard calibration curve, what we have got in matrix here. This is the equation. For now I am doing for peak height. So I should take into consideration peak height y is equal to mx plus c equation. So in place of y, I have to keep the height of that particular time interval height in this equation. Y is equal to mx plus c. After that, we have to plot the graph in scatter. So here you can see the typical pattern of oral absorption. So here after 1.5 there was decrease in like what is called peak height. Then again it has at 3 hours it has increased, again it has started falling back. So this is like up to here 1.5 hour I have shown you increasing trend. Now this is like here, this is 0 minute. This is like pink is 2.2 hours. So you can see it has decreased. Again 3 hours it has increased this brown color, and then again it has started decreasing here. And this violet color is 36 hours. So it has completely come back to 0. And this is all that because of proper washing of the syringe. These are the interferences. So this should not be there. So this is that semi-logarithmic plot of like plasma concentration versus time. So here that slight decrease and increase. So this may be because of enterohepatic recycling. Okay, this is all about how animal experimentation is done. So in tomorrow's session, Dr. G.S. Rao, he will be discussing about from this data how to go for deriving the PK parameters. So once we have done the experimentation, that method has to be validated. So for validation, generally in our laboratory, we are following US FDA guidelines. So for specificity and selectivity, like 12 blank samples from 20 blank samples from 20 different sources, they are injected, so that we can see that whether here suppose here this is our meloxicam peak. So we have to see that here there is no matrix interference. So for that reason 20 blank sample we have to inject it. So that is for specificity and selectivity. Now coming to linearity, so here we have taken peak height into consideration. So height versus like time we have plotted, and then we have got the for quantification of meloxicam, peak height and peak area versus concentration was plotted, and linearity was analyzed by least square regression analysis. Then for checking the precision, intraday and interday variations we have to do. So for intraday variation per day, like at 3 hours interval, 3 different concentration, low, medium and high were injected at 3 hours interval for 4 times for intraday variation. And for interday variation with the same chromatographic condition and that same sample 3 concentration for 4 different days, it was injected into the HPLC system. And the assay precision was calculated by percentage RSD, root square deviation. So that is nothing. The formula is standard deviation by mean into 100. So M is the mean of the experimentally determined concentration, and SD is the standard deviation of the mean. Now accuracy was checked by limit of detection and limit of quantification. So generally here I have said that at the like blank sample, why we need to inject is so that it should not have any noise or any peak at the retention time where our test compound is there. So suppose if at all it is having any noise, then that noise we have to, that area or height, we have to take the mean and we have to calculate the standard deviation. So for limit of detection, the detection limit should be thrice the standard deviation, and quantification should be 9 times the standard multiplied by the standard deviation. So suppose if at our, like in our thing, we have seen that at retention time of our meloxicam, there is no appreciable peak in the blank sample. That means it is 0. So 0, so for 0, the standard deviation will be 0. So 0 multiplied by 3 will be 0. So like up to 0, so 3 times of that 0 will be like we can detect. So here in our thing, we have detected limit of detection. Here we were having 0.03 concentration. In previous slide, I will show you. So here limit of detection was 0.03, as well as in our procedure limit of quantification was also 0.03. After that, like recovery, like we have to find out the percentage recovery, that whether our test, our extraction procedure is perfect or not. So what we have to do is 3 different replicates at low, medium and high concentration has to be spiked. And then whatever the concentration we are getting, that percent recovery will be compared with the peak height of the extracted analytes to the peak height of the non-extracted standards. That means peak height of the in matrix divided by peak height of the that particular concentration in the mobile phase we have to compare. That will be our percentage recovery. Then robustness of the method can be checked by making slight changes in the flow rate, column temperature and pH of the buffer in the mobile phase. So if we make these slight changes and temperature, so slight changes in the mobile phase, at that time if still the compound is getting detected at the same retention time, that means it is the robustness of the method, that wherever the wherever the world we are doing the same chromatographic condition, if we are following, we are going to get this peak at the same retention time. So that is called robustness of the method. So this is how we are validating our method, what we are developing in our department. Thank you one and all.
Yes.
You check out the feedback and see the any
So there
doubts
are
are there.
no questions in the feedback charts or live chart in YouTube live chart.
I think
There are
somebody
no
asked
questions.
someone, no, somebody asked washing for how much acetonitrile is required. Somebody asked, it seems, just check out YouTube link.
When we want to wash the column, then like if suppose today I am running the HPLC system and tomorrow again I want to run the system, so it's better to wash the column for minimum 1.5 hours with milli-Q water or HPLC grade water. That is
The question is, Afroz,
yes sir.
for washing, what is the concentration of the acetonitrile?
It is fine. We
For
don't.
needle washing or for washing of the column?
Just for washing.
Washing, I think that means column only if you want.
Okay, so for column washing, that's what I'm saying. So for washing of the column, if I am continuously doing the experimentation, so in that situation, I can wash the column with HPLC grade water for 1.5 hours and I can put off the system. But if I want to put off completely the system, then after 1.5 hours of washing with water, we have to wash with 100% of acetonitrile, pure HPLC grade acetonitrile, and for minimum 1.5 hours, and then we have to put off the system.
And another thing, they have to wash with the low flow rate.
Low flow rate, that is 0.3 ml per minute, so that the washing will be proper. But before washing with acetonitrile, first we have to wash minimum 1.5 hours with water, milli-Q water, so that whatever the matrix is there attached in the column, it is completely removed. And then whatever the mobile phase, everything will be removed, and then it has to be washed with acetonitrile to preserve the column, because we can't keep the column in water for a long time because chances of fungal growth may be there.
Okay.
Okay, thank you, Dr. Afroz Jahan.
Thank you.
Very nice presentation, very elaborative, and almost all points covered. And it is almost just like watching by standing beside the where experiment is conducting. Thank you very much. So with this, I conclude today's session. Tomorrow we have a session on time versus concentration curve for pharmacokinetic analysis of compartmental and non-compartmental analysis using PK solver.
Sir, excuse me, sir. Sir, somebody has asked that why we need to increase pH to 6 of mobile phase. So here, like in my presentation slide, I have already said that the structure of the meloxicam, it is having amine group. So amine group means it will be better detected or best detected when the pH is basic in nature. That's why we need to increase the pH to 6, so that it is somewhat basic in nature.
I can add. I will add something to this.
Okay,
I think whoever asked for this particular mobile phase, we kept 6 pH. taking in view of the, as already Afrojahan presented in her slides, there are two pKa values of meloxicam. Generally, any compound, when you can pKa value at that pH, it will be 50% ionized and 50% non-ionized. So we HPLC, we have to make all the compound non-ionized so that it can be soluble in the mobile phase. We can detect completely. Whether since the pKa value of the meloxicam is 3.8 and around 7.6, there is another thing. So we have seen in between. So we have increased the pH towards 6 so that completely meloxicam can be unionized so that it can be detected. Okay, you can also ask that, suppose I can reduce the pH of the buffer by again making 2. But most of the times, if you want to save the column of life, it is 2 to 8 is the best pH range where you can keep the columns for longer time. Yesterday, Dr. Bharvi emphasized that point. So whatever the columns we are using in reverse phase, they will be best maintained at 2 to 8 pH. So that is the reason why we have taken meloxicam pKa value into consideration, 3.8 and 7.96, so that we brought the pH of this mobile phase to the 6. Using triethylamine is another point because, as already Afro said, meloxicam is having amino groups. Triethylamine, generally, it is a modifier in the HPLC method. And it is amino group, generally, it have towards add some basic nature. That's the reason why our mobile phase pH, when it is 4, we increase it to the 6 by using triethylamine to as an organic modifier in HPLC method. Another thing, tailing of the peak can be also reduced by using triethylamine. That is the reason why we maintained 6 pH and we added triethylamine. These are the two reasons. One is in between the pK value of the meloxicam. Another thing is reducing the tailing of the peak. So I hope this will be clearing the doubt which have been somebody expressed in the chat box. Okay. Over to the presenter.
Okay, sir. So with this, we thank Dr. Afrod Jahan, and I also thank Dr. G.S. Rao sir for clarifying the doubts. So the tomorrow, the day 3 session is on time versus concentration curve for pharmacokinetic analysis of compartment and non-compartmental analysis using PK solver. So I thank all the participants for attending this session. So we'll meet tomorrow at 11 o'clock for day 3 session.
Okay, another thing, sir. Actually, whatever the data we have put today, the meloxicam time versus concentration, the same data will be used tomorrow for calculations so that it will real-time analysis for the listeners and viewers.
Okay, sir. Thank you, sir. Thank you very much, sir.
Okay.
Thank you, one and all. Closing the session, sir.
Okay.